Hello everyone. Good morning, good evening, good afternoon. Dear authors and invited guests, welcome to the technical session 7P. Myself Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, UK. The 10th edition of the conference is being organized in the hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you can stay connected with us till the closing remarks. If you have any queries or any kind of update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session. We have Dr. Mohammed A. Twat. Sir is a professor at Thomson Rivers University, Canada. His teaching interests are optimization, operations research, and data mining. His research interests are algorithms, inspired computing, computational intelligence, evolutionary computation, artificial intelligence, and their applications to data analysis, big data, optimization, engineering problems, optimal control, wireless sensor network, and operations research. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Thank you so much here. It's my pleasure to anticipate for this conference here. It's my real pleasure. Thank you.
Thank you so much, sir, for joining in. I would also like to introduce you to Dr. Sham Akash. Sir is a professor in Electronics and Communication Engineering Department and Dean International Cooperation and Projects at IMT University, Gwalior. He has been serving as a TPC member in IEEE and Springer conferences. His areas of interest in research are low power VLSI design, modeling, fine fit based memory design, circuits of future VLSI technology, digital design, and FPGA implementation. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Thank you very much for inviting me as a session chair of this conference. My best wishes to all the authors. They can publish a very good work in the very good work in this conference. Thank you very much.
Thank you so much, sir. So now I will be starting with the papers. First, we have Miguel to present the paper titled Artificial Intelligence Model for Predicting Weather Conditions at an Airport. Are you there?
Thank you. Good evening, London. I'm pleased to present my research, artificial intelligence model for predicting weather conditions and rainfall. I'm very happy to share my experience with you.
Thank you so much, sir. You may please begin with the presentation.
Okay.
You can share your screen and begin your presentation, sir.
Okay. Good. Please give me a second to share my screen.
Yes, sir. Your screen is shared.
Okay. Good evening again, London. I'm pleased to present my research on artificial intelligence model for predicting weather conditions at airport. Bad weather conditions, such as strong winds or fog, can represent a significant danger to aircraft during takeoffs, landings, and flights. That's because forecast weather conditions at airports can affect the safety, efficiency, and comfort of flights. Therefore, learning to predict weather behavior based on prior information is important. This is the main reason why this research on the prediction of weather conditions and forecast for Lima, Peru is presented. To do this, a set of previous data was used to reach the J48 random forest support vector matching Bayes-Net and neural network algorithms were applied. Random forest algorithm obtained the best behavior with accuracy near to 77% for validation process and accuracy of 68.6% for the test process. Finally, as a proof of concept, a Java application was implemented. Dataset. For prediction tasks using machine learning, the first thing that is required is the right dataset. The data were obtained from the National Center for Disaster Risk Assessment, Prevention and Reduction, CENEPREC for its acronym in Spanish. This Peruvian center gives us risk scenario forecasts in collaboration with scientific and technical institutions from Peru, such as CENAMI, INGENMED, and PINEIR. All of them Peruvian centers. The attributes of the data obtained are displayed in Table 1. Each one was taken from December 2009 to July 2024, making a total of 6,058 records obtained. The attributes taken are known of data, the maximum temperature recorded in degrees Celsius, minimum temperature recorded in degrees Celsius, air cooling, temperature for water vapor to condense into dew, relative humidity, wind speed in kilometers per hour, wind angle in sexagesimal degrees with respect to the north, percentage of cloudiness, visibility in kilometers, solar radiation in watts per square meter, solar energy in thousands of joules per square meter, UV index, two classification label for today and classification label assigned for class tomorrow. For each particular record, the values that will be used for the field of class tomorrow, the white to be predicted, were constructed by copying in today the known weather conditions of what will occur tomorrow. The labels of the tomorrow class, which will be predicted, are cloudy, partial cloudy, rainy, and clear. The process to obtain a secret data set for machine learning was as follows. Data preprocessing process in which some attributes were removed because they contain the same value in the entire data set. The records with the windy tag were also considered to be eliminated from the subsequent analysis due to their low presence. Identification of outliers. Remove 305 records, extreme data, remove 47 records, data augmentation. In an initial analysis of the data, it is observed that the class tomorrow to be predicted has an imbalance in the number of records that explain its four classes. So, it was necessary to apply data augmentation techniques to create missing scientific data. After augmentation process, similar numbers of records were obtained for the four labels, near to 2,025 records for each four classes, which makes a total of 8,099 data records for each 13 attributes. Adding randomness is a very important task because it allows the training process to be more impartial. Attribute importance calculation. The highest value corresponds to the attribute with its name of the month, perhaps because the climate is cyclical, with 73% and maximum temperature recorded in Celsius degrees with 69%. The lowest values uh, correspond to relative humidity with 9% and wind angle in 61 degrees with respect to the north of to the north with 2%. Training validation set and test set. The data set obtained was divided into two groups in a proportion of 80% to create the training and validation set that is equal to 6,479 records, and another in a proportion of 20% to the test set that is equal to 1,620 records. Modeling, training, validation, results. The process and adequate data set was exposed to several algorithms in order to identify the one that obtains the best prediction accuracy for validation. The behavior was analyzed with the following algorithms. For the J48 algorithm, the model obtained an accuracy of 71.29%. For the random forest algorithm, the model obtained an accuracy of 66.80%. For the support vector matching algorithm, the model obtained an accuracy of 69.39%. For the Bayes-Net algorithm, the model obtained an accuracy of 75.87%. For the multi-layer perceptron algorithm, two situations for the learning rate were analyzed. The type 2 that obtained an accuracy of 72.68% and the type 4 with that obtained an accuracy of 73 and 19%. After applying the mentioned algorithms, the highest value of accuracy obtained equal to 66.80% corresponds to the random forest algorithm. Prediction using test data set. For the prediction process, the model obtained by applying the random forest algorithm was used because it obtained the best behavior during the training and validation process. Here, it obtained an accuracy of 58.6% and area under the ROC curve equal to 939 when it was exposed to previously unknown records. Both values are considered good. Sample point A. As a proof of concept, a Java console program was developed which uses weights from previous training. Its main process are indicated here. From number 1 to 6. Number 1, loading the necessary packages. Number 2, loading the previously trained model file. Number 3, defining the structure of the instance that will be
Sorry
used
to interrupt you, sir, but you have 2 minutes to conclude your presentation.
Okay, okay, number 4, creating the instance that will receive the data. Number 5, requesting the input of today's attribute values that will use that for the prediction. Number 6, running the prediction for tomorrow's weather conditions at Jorge Chavez Airport. The code can be consulted and downloaded from these links shown, which are also included in the previously delivered paper. It works by entering the parameters measured today, and when you press enter in your keyword, the prediction of weather conditions for tomorrow is shown. Conclusions. The previously analyzed researchers agrees that it is difficult to predict the weather conditions because it is considered a complex and chaotic system by nature. However, in order to try to predict the climate conditions, a data set was obtained with records of variables measured daily for a period of near 15 years. This data set was processed by eliminating outliers and extreme data, and then balanced with the creation of scientific data. So, in this research, it was found that the best machine learning model to predict tomorrow's weather at Jorge Chavez Airport is the one provided by the random forest algorithm. Okay. That's all I wanted to say, and I am very grateful for the opportunity given to me. Thank you very much. Thank you.
Thank you so much for your presentation, ma'am. Sir, do you have any questions?
Yes, can I ask a question?
Yes, sure, sir. Please.
Excuse me?
Yes. My question to the author is that, can you tell me how can AI predict the natural disasters?
Excuse me, could you repeat?
Can I repeat my question?
Yeah.
How can AI predict natural disaster?
Natural of
Are you listening? Are you listening my question or not?
not very well, excuse me.
How can AI predict the natural disaster?
Excuse me, I couldn't understand your question. Maybe your
Is-
audio is not good.
Now it is okay.
Uh, well, but if you ask me about my how can I predict the weather conditions, maybe
Okay.
I put time. Well, I use a program called Wake Up. It's
Okay.
a
Okay. Okay.
known software that or many of its algorithms are there. And maybe for the future, I will try to use neural networks using other technologies as sensors or like so. No? Thank
Oh, okay. Thank you. Thank you very much.
you. Okay.
Sir, do you
Okay,
have any questions? Yeah.
can I have another question quick here? You have applied for one report. So, can you apply your machine learning approach here to predict weather in different other airport, like more than you take a different data set? Is not only one data set for one airport. So I would like to see if you have another data set from a different airport so that you can see your result is the same or not.
Well, I suppose this is very different with another data set because, for example, in Lima, Peru, sometimes the weather conditions don't have windy, not are windy. No, sometimes the sky is very fog. No, well, I don't know how to say that, but in another country, for example, maybe I don't know, Africa, no, for example, the way the sky is sometimes very clear, no, and windy. This specific research was the data was obtained from Lima, Peru, no, for this specific I4. But I suppose, the structure of the research would be the same, no? But many of the results could be different.
All right. Thank you. So is that is the time is over now, or I can ask another question? No.
No, you
Ah,
can, you can ask another question, sir. No problem.
Yes. If you have for the missing data, I think I don't know if you did you collect this data by yourself, or it's already benchmark data, so the data somebody else collected?
No, somebody else. In Peru, we have a scientific institution that collect this data, no, this data. No? I obtained this data from them, no, and I used
I see.
for my research. Yeah.
Is that where it was missing data? When you get the data, is there missing data, missing some information there in the data, or it was no missing?
Yes. Sometimes when you recollect information for sensors, sometimes it's frequently or often to have missing data. Huh? Yes, but using process like data augmentation, not to create scientific data, no, it's possible to complete this missing data.
Sure. Thank you.
I use. Yeah. Okay.
Thank you so
Thank you.
much for your presentation. So we'll be
Thanks.
moving on to the next presentation. Next, we have Miftachal Huda to present the paper titled ChatGPT Enhanced Instructional Design Potentials to Empower Learning Resources and Tools. Are you there? Are you there? So moving on to the next paper, next we have Miftachal to present the paper titled Digital Administration System for Education Institutions, Insights from Technology Adoption to Beneficial Contribution. Are you there or any of the co-authors here? Next, we have the paper Digitally Gamified Instructional Design, Insights into Empowering Digital Learning Environment. Do we have Miftachal Huda or any of the co-authors here? Okay, so we'll be moving on to the next presentation. Next, we have Marwa Mustafa to present the paper HHO Enhanced Deep Learning Approach for Accurate Papilledema Detection. Are you there?
Yes, I'm exist.
Yeah. So you may please begin with your presentation. You may please begin with your presentation now. Your screen is visible.
Okay.
Yeah.
Hello, everyone. This is Marwa from Arab Academy for Science and Technology. Paper title is HHO Enhanced Deep Learning Approach for Accurate Papilledema Detection under supervision Prof. Dr. Alia Youssef and Dr. Nahla Bilal. This is agenda of my presentation. At the first, the human visual system develops over several years during early childhood and fully matures around the age of 7 years. There are potentially clinically relevant issues that may emerge or manifest. We must know the question, what is the papilledema? Papilledema is a syndrome of the retina in which retinal optic nerve is inflated by elevation of intracranial pressure. Pseudopapilledema also present with elevated optic nerve, head appearance, and blurred margins. My research to classify the true papilledema and pseudopapilledema. There are a similar signs, elevation of intracranial, as we can see here image. Key features on the patient's optic nerve analysis. The motivation, early detection of papilledema is important to initiate prompt treatment and prevent further complication. Many regions, particularly in low resource setting, lack the adequate medical professionals to detect and manage this condition effectively. There are many traditional papilledema detection methods. Challenges in papilledema detection, such as time-consuming, subjective, inaccurate. So we designed and implemented an AI-based system that can accurately and efficiently detect papilledema from optical disc images. We have the objectives such as identify papilledema at its early stages and classify true and pseudopapilledema. The second objective, by leveraging artificial intelligence, we can improve healthcare accessibility, reduce the burden on a specialist, and ultimately prevent vision loss and neurological complications in patients. There are modalities in retinal image, fundus imaging, OCT, and OCTA, and methods based on AI to solve these problems. Traditional machine learning methods and deep learning problem solutions. Maybe early detection, diagnosis, grading, and classification. In the literature review, we make a comparison between other previous studies on this topic, on this papilledema, to differentiate between optic neuropathies and pseudopapilledema, or to classify severity of papilledema on ocular fundus photographs. This is papers worked on the same topic, and they used Google Net Inception transfer learning and deep learning system composed of a segmentation network and classification network. Here in this paper achieved accuracy 95.89, accuracy here in the second paper accuracy achieved 87.9. As we can see, this is paper purpose of this paper, automatic detection of pediatric papilledema. They used optic disc localization and achieved accuracy 80%. And the master paper that enhanced our proposed method, enhanced this paper. Publication date of this paper 2023, and the purpose to classify retinal fundus images as the papilledema or pseudopapilledema or normal. They used CNN and EfficientNet B3, the same data sets that our proposed model worked on it. They achieved result 98, and we can see, we will see in the next slides the results or comparison between this and our proposed. Proposed system architecture divided into 4 stages. The first stage is pre-processing. Pre-processing here, dataset, input image 100 by 100 size, and make pre-processing on this image to correct any errors on on this image and make a data augmentation. So the second also the second phase, the second stage is classification using CNN with different layers. This is layers. We make integration. We made integration between between CNN and HHO algorithm to identify hyperparameters by fitness metric and CNN model training by HHO algorithm, like this. Here CNN model, the layers are used. HHO algorithm used HHO algorithm to finding optimal solution efficiently, enhancing model performance. How it works, HHO algorithm. We have input papilledema dataset, lower bound, upper bound, dimension, search agent, objective function, and output of this algorithm, optimal hyperparameters for CNN model, performance evaluation matrix. At the first defined fitness function that search for hyperparameters of CNN model using the training data for 2 epochs. Defined HHO function create an initial location and energy for the rabbits, currently the best solution. Set Harris Oaks location, this is the search agent. A loop should be used, the main optimization process to be performed for a maximum iterations. Calculate each solution's fitness. If a better solution is found, update the best solution. As Harris Hawks become more fit, they update their location. In the end, the fitness value and the best solution are printed. This data set divided into 3 categories, normal image and pseudo papilledema and true papilledema. Data set collected from Kaggle and the number of images for each category, as we can see. We made the preparation and pre-processing on this data set. This is a sample of images in the data set. Experiments hyperparameters. We have CNN parameters and HHO parameters. CNN parameters like optimizer, activation function, dropout rate, epochs, but HHO parameters, objective function, lower bounds, upper bounds, dimension, and search agent number 3, max iteration 4. Now we as we see this table based on the same dataset comparison based on the dataset. This is the paper. Paper used the same dataset we that use. They used.
Sorry to interrupt you, but you have 2 minutes to conclude the presentation.
Okay. They used efficient NetB3 and achieved accuracy 98.5. Our proposed model achieved 99.7. And this comparison between previous studies and proposed model, as we see, this is models transfer learning and deep learning they used. But we proposed proposed model here achieved the highest accuracy, 99.7 in all of them. We applied some models on the data set, like efficient net B3, B0, efficient net B3, dense net 1-to-1, VGG 16, and we observed from the results proposed the model with HHO achieved the highest results of the highest results of all of them. We concluded that with HHO, the performance of the models is enhancing using underlying optimization principle, and in comparison to models such as efficient net B0 and others, proposed model demonstrated superior performance, achieving the highest accuracy, 99.7. In the future work, the identical system could potentially be extended to offer more thorough categorization of diseases. This is reference. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yes, I have a question here. Thank you so much for the nice talk here. It's a nice talk here. So my question here, you are using HHO. So did you use other meta-heuristic algorithm for the sake of comparison to see HHO, the performance of HHO compared to other meta-heuristic algorithm, or just you are using only HHO for hyperparameter?
No, I'm used HHO only after transfer learning models and CNN model to enhance hyperparameters of CNN.
Yes, I know. But why you are using only HHO? You have thousands of meta-heuristic algorithm people always can use. So is there any particular you pick random HHO, or there is a reason for HHO? Because if you compare HHO with other meta-heuristic algorithms, you will be surprised. Maybe other algorithms perform better than HHO. I'm telling you that's my area. So I'm asking for something I know. Just yeah. So if you compare with other meta-heuristic algorithm, then you will see the paper will be good, stronger.
Yes, inshallah, يعني, I will try.
Sure.
I will try.
Thank you,
Doctor. Thank you.
So thank you very much for your presentation. My question is to you: what is the best way to detect the papilledemia?
Sorry?
What is the best way to detect the papillomedia?
The best way?
Detect.
Traditional
Detect.
to detect traditional methods or AI methods.
I'm talking about traditional.
Traditional OCT from fundus image photos.
Yeah.
OCT and clinically with OCT or OCTA. This is traditional methods.
Okay. Thank you very much.
Thank you
For your presentation. So we'll be moving on to the next presentation. Next, we have Otu Obina to present the paper titled Unveiling Community Policing Challenges in Nigeria Using Green Helg's Meta-Analysis Approach. Are you there?
Yes, I am here. Good evening, all.
Good evening. You may please begin with the presentation.
Yeah, can I share my screen? All right.
Yeah, you can share your screen.
Can you see my screen now?
Yeah, we can see your screen. You may please begin now.
All right. Once again, my name is Obinna Otu. I'm a PhD candidate in Swansea University, and my area of research is human-computer interaction and AI. You might be wondering, especially those in AI, why an AI interested or human-computer interaction interested researcher is talking about unveiling community policing challenges. Actually, in human-computer interaction, we tend to design technologies for mostly users who need them. So, and as such, if the police needs technology, we work with police. So in this time, we started to look into community policing challenges in Nigeria. And of course, we know community policing is a kind of a discipline where citizens and the police work together to reduce crime. And of course, there are numerous community policing technologies like the surveillance system, communication system, and thereabout. So in looking into trying to design tech for community policing for Nigerians, we needed to understand the challenges first. And in human-computer interaction, there's what we call design thinking methodology. It's just an approach that has 5 major steps. And the first step is very, very renowned in computing research called empathy, where you put yourself into the shoes of whoever you want to design for, empathize and know the feeling. From there, you define the problem. So we really needed to understand the challenge. So this is a preliminary stage of our research. So in understanding the challenge, we wanted to understand this comprehensively, having known that many people have understood the challenge of community policing in so many lenses, but yet the problem persisted. So we needed to understand it holistically. And as such, we employed greenhouse meta-analysis technique. This greenhouse is just a method where you combine social scientists, computer scientists, and other branch of sciences that have tried to understand this problem or to understand this problem so that you have a comprehensive outcome of the challenges, so that if you are giving it a solution, it will be a comprehensive solution. So that was what we did. And when you talk about systematic research, systematic literature review, and combining it with meta-narrative analysis, you're talking about following a procedure. Following a procedure, which the one that is common in human-computer interaction is the one we call greenhouse and Prisma design. Now, the Prisma is a protocol. That Prisma has steps you must follow. First of all, in Prisma protocol, you define your databases, the databases you're going to use. You define the selection criteria. So the databases we used in ours was the ACM Digital Library and also the Science Direct. But before we went to databases, I wanted to look at the research question we asked. What are the challenges of community policing initiative in Nigeria? That was the major question we asked. The second question was, what can be done to enhance community policing initiatives in Nigeria? The second question. Now, to answer the first research question, we now follow the method I already mentioned. And as such, we created our keywords. The keywords we created were community policing and challenge and Nigeria and technology. And of course, in ACM Digital Library, it gave us 8 document results. The second one, we twisted it by quoting community policing and challenge and technology. We got 60 document results. The third one, we twisted it again. So why we continue to twist is to add rigor to the result we are getting, because as you can see, the limitation of this work was the few databases used. we would have expanded our search to maybe Google Scholar and to maybe Scopus and other databases. But because we used only 2 databases, we had to twist our search keywords into 6 places to be able to add rigor to the search we did. At the end of the day, the first search, we got 8 document results. Second search, 60 document results. Third search, 145. Fourth, 28. Fifth, I'm surprised this thing is moving when I don't want it to move. Sorry about that. I'm not the one I don't know, maybe it's my laptop. I hope you're hearing me. Can you hear me, please?
Yes, we can hear you.
Okay, so because my slide is moving even when I don't want it to move, my laptop is just running helter-skelter. Okay,
Okay.
so
We
the
can see
first
the
document
document
result,
and slide.
yeah, the first document result is 8, second 60, third 145, fourth 28, fifth 311, and the sixth 1129. So at the end of the day, we implemented our criteria on this document results. So, and this is the Prisma diagram. So the total search was 1,696. So when we modified by content validity, like number 1, those that were published in English language, those that did not include Nigeria in their abstract and in their keywords, it reduced to 296. So we modified based on relevance. After reading the abstract completely and the conclusion, it was remaining 52. Then we modified based on missing words. And at the end of the day, we found 17 document results. Now, with these 17 results, we conducted our analysis. And mind you, in this approach, sorry, this is just moving, but I'm almost done. In this approach, there is what we call blind review. So these 4 people who have come together to work on this paper, that's the 4 authors of this paper, reviewed independently, looked at these papers independently using Ryan, what we call Ryan AI dashboard. The Ryan AI dashboard enabled all of us to make judgment on the papers we selected. And at the end of the day, we found these results. So the first result was the death of modern technologies, with the studies that discussed about the death of modern technologies in Nigeria. So 1, 2, 3, 4, 6 studies, 5 studies discussed about death of modern technologies. And the next one was the lack of trust, accountability, and transparency. The next one was improper citizen participation. The next one was unwillingness to share information. These were the 4 major challenges community policing was facing as identified in our results. So, and conclusively, the study was able to comprehensively unveil the challenges of CP in Nigeria, and then highlighting the technologies used in community policing on the surface. So, and concluded that there is need to conduct a systematic literature review that will comprehensively explore relevant technologies applied in this context and how each has fared from inception. So with our findings, someone can look at this table and say, wow, these 4 themes are actually the major issues being faced by community policing in Nigeria. That's all. Thank you so much for listening. And once again, our topic is unveiling community policing challenges in Nigeria using greenhouse meta-analysis approach.
Thank you so much for your presentation. Sir, do you have any questions? Sir, do you have any questions? Yeah.
Yeah. My question to the author is that what is the objective of research article?
The objective is to unveil the challenges of community policing, like to find out the challenges. Okay.
Okay. Okay. Thank you.
Thank you. Sir, do you have any questions?
No, thank you.
Okay. So Now, I want to sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days, and further, all the papers have already been forwarded to the sprinter. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. Before ending this session, I would also like to take a moment to thank our session chairs for chairing this session. Professor Mohammed A. Toheed, thank you so much, sir, for chairing this session. Would you like to share a quick closing remark with us?
Again, here, thank you so much. Here, it was a very wonderful presentation, very excellent presentation I have seen, and it's a real pleasure to anticipate in ICICT 2025. Thank you.
Thank you so much, sir, for your valuable presence. I would also like to take a moment to thank Professor Shyam Akash for chairing this session. Thank you so much, sir. This is a token of appreciation on behalf of Team
I have a
IC.
question, please.
Thank you very much for the board member, committee members. They inviting me to chair the session of ICICT 2025, and we have conducted a very good session. My best wishes to all of you. Thank you very much.
Thank you so much, sir. This is a token of appreciation to the chair on the behalf of Team ICICT 2025 and Global Knowledge Research Foundations and partners. Now, I would request everyone to turn on their cameras for a quick snapshot before we end this session. Thank you so much, everyone, for your presence. Take care, stay safe. Thank you.
Thank you. Thank you.
Thank you, everyone.
Thank you.